Okay, so we acknowledge we're hosted on the lands of Mississauga, Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize enduring presence of all First Nations, Métis, and Inuit people. Okay, today's day 3, July 6th. We're going to talk about simplifying rational expressions. What are rational expressions? That's number 1. Multiplying rational expressions. Rational expressions are basically fractions. Okay, they're expressions that are like fractions. Okay, so we'll get into that. So it's like adding fractions, simplifying fractions, if we want to call it like that, but they're expressions. Adding, subtracting, rationals, which are fractions, expressions. Okay, and there's a quiz due today. So again, this unit is always in content, so we go into content. No, I don't take attendance like that, okay? So you're here, that's good. I can always check if you're actually in the Zoom because the Zoom is being recorded. So afterwards, it'll show all the participants in the Zoom, so I don't have to actually physically count. Zoom does it for me. Okay, so we're going to January, sorry, not January, July 6th, simplifying polynomials. Nope, we did that. That was yesterday. Rational. Rational expressions, okay? So there's a lesson. There are video lessons. So if you click on here, this will give you the PDF of what we need to know, okay? And if you click it on over here, this will actually give you the videos. Okay, so we're gonna go through the video and of simplifying, multiplying, dividing, and adding, subtracting. And then you have a worksheet, worksheet 1, worksheet 2, and worksheet 3. Okay, so 3 worksheets. Again, the worksheets are not for marks. It's for you to practice, right? You need to know, you need to know the lesson, right? You need to practice on the lesson that's been given, right? So that you do the worksheets. And again, the worksheets have the final answers at the end, like a textbook would. But if you're one step by step, I got to see you actually attempt it. The only way for me to see actually attempt it is if you submit into the Dropbox, take a picture, scan it, whatever, put it in the Dropbox for that particular assignment. Then I will reply with the step-by-step answers. I don't just give out the step-by-step answers, okay? Otherwise, you're not learning. Like you guys actually do work, and then you would fail the test. The test is coming up tomorrow, the unit test. I'll talk about that tomorrow. Let's just focus on today. So let's click on the first video, simplifying rational expressions. Where are these people? People are trying to get in. Okay, there you go. So it says here, what I have here, what is a rational expression? A rational expression is a fraction in the form of, you got P over Q. So basically P is a function, Q could be a function. So 2 functions like on top of each other, okay? It could be a polynomial or could be a monomial. So this example here, 3 over X, is basically a monomial, right? It is because monomial means one term. Just remember that, right? Remember that? Polynomial means more than one term. Terms are separated by plus or minus, right? So over here, this example here with my mouse, you can see, has 2x plus 9. So that's a binomial over a monomial. So this is what we talk about a fraction, right? Here, this is basically, this one over here is a binomial over a trinomial, okay? So let's get into it. Let's watch the first video. I gotta check the sound. I gotta make sure you guys can hear it, because sometimes.
You know Wix, do you really?
Can you guys hear it? Did you guys hear it? Did you guys hear the video?
First up, we've got shake video masks. You can use
No? Yes? Do you hear the video now? I see yeses. Whoever's
Whoever's
saying no, you're looks like you're by yourself. You got to fix maybe your on your end. It's very quiet. Okay. Do you hear it
Okay, I'm just
now?
going to do the first part of this
Is it better
lesson,
now?
the restricting and simplifying part for rational expressions.
Okay, so yes. Okay, good. So let me maximize the screen so we can look at it. So simplifying rational expressions. How long is this? I may have to modify the time. It's 20 minutes, but I'm going to fast
Then
forward.
I'll post a video for multiplying and dividing rational expressions after. So like I said, we're just going to do part 1 and part 2 in this lesson. So first of all, let's start off with what is a rational expression. So a rational expression is basically the quotient of two polynomials. So we have a polynomial function in the numerator, p at x, a polynomial function in the denominator, q at x, and you have to keep in mind whenever we have a rational expression, the denominator cannot equal 0 because we can't divide by 0. So we always have to, when we're simplifying rational expressions, take into account what values of x would make the denominator 0, and then state the restrictions on the denominator by saying that x could not equal those values, because we can never let the denominator equal 0. So an example, here's an example of a graph of a rational expression. We have, I don't know if you can see the equation here, it's x squared minus 2x.
Okay, I'm going to pause a little bit, right? Okay, people are still coming in. You guys got to come on time. Well, anyways, it's being recorded, so you have to watch the video. I hate when you guys miss the beginning of the video and then I'm explaining, and then you have to go back and watch the beginning of it while you were here. If you're going to come, you might as well just come at the beginning so you don't miss stuff. But anyways, here is a rational expression, like what we said. A rational expression. I know sometimes there's issues with PCs. I get it. I know. There's been issues with mine too. Okay, so here's a rational expression. You have x squared minus 2x divided by x minus 2. So now, when you look at this, right, you have to, like, you know, there's cases where you have to simplify, right? So let me just do this one as an example. Get my annotate. So annotate. So you have something like, so this is it here. F of x equals x squared minus 2x. Oh, come on. Divided by x. Oh no. I'm just saying my pen is like acting up now. Okay, so something like this, you want to modify. You want to modify, right? Like when I say modify, I mean to say simplify. You want to simplify, but now the thing is, if you simplify this, before you simplify, you have to look at what are the restrictions from the beginning. The beginning, we talk about restrictions is what cannot be that value. For example, we're looking at x now. What x cannot be? In this case here, x can be anything, but it can't be 2. Because if x is 2, what happens is if this is 2, 2 minus 2, that means you have a 0 in denominator. You can never, ever have a 0 in denominator. So therefore, x cannot equal to 2, right? So say we modify it. That means we'll factor out maybe the x up top. So if I factor out the x, I'm going to have here x. I'm going to have here then x on the inside. If I can get the pen working, minus 2. Okay. Come on, pen. Divided by x minus 2. Okay, and then, you know, if we're, you know, we're looking at it, when we can cancel that. Oh, try to change color. We can cancel that. And then what we're left with is x, come on, change color. And then what we're left with is x is equal, the whole thing equals to 2, or at x, right? So your answer is x. But we have to state the restriction that So how do you, f of x equals to x, that means here my slope is 1 and I don't have a y-intercept. That means I start from here and my slope is 1. That means I rise 1 and I run 1. I rise 1 and I run 1. I rise 1, then I run 1. Okay, that's my slope. But if that's the case, I just draw a straight line, right? I can just draw a straight line. But wait a minute, I can't. The thing is though, x cannot equal to 2. If x cannot equal to 2, that means I have to draw a circle at 2. What x is equal to 2, because I can have a straight line, but x cannot equal to 2. Because based on my rational expression, I can't have a 0, right? It looks like a regular, f of x equal to x, looks like it should just be a straight line with a slope 1, but no, the original was a rational expression. And as a result, if you're looking at a rational expression, you gotta look at what cannot your denominator be. It cannot equal to 0, therefore my value of x cannot equal to 2. So that's why we have something like that, okay? So that's something to think about. I'm gonna clear this and play the video and talk about that a little bit.
Over x minus 2. Later you'll learn how to simplify something like that, x squared minus 2x over x minus 2. That could be factored, x times x minus 2 over x minus 2. And then the x minus 2's could be canceled. So it's really just the graph of y equals x, but with one key difference. You'll notice right here, there's a hole in the graph, a hole at x equals 2. Why does that happen? Well, if we look at our denominator of the function, x minus 2, the denominator, keep in mind, the denominator can never equal 0. Therefore, x cannot equal 2. That's why we see a hole at x equals 2.
Yeah, so I just said that. Let's just fast forward a little bit. Okay, so here are rational expressions. State the restrictions for the following rational expressions, right? So if I look at this, I can easily just say right away, if I'm just going to do state the restriction, that means the bottom. I'm going to fast forward some things, right? I don't have to hear him say it because I'm going to just say it too. But basically the bottom cannot equal the denominator, cannot equal to 0, or the bottom of the fraction, right? So if I'm just stating the restriction, x cannot equal to 2 over here, x cannot equal to 3, and it cannot equal to -4, right? If I put -4 here, 0 times anything is 0. That means I'm dividing by 0. And if I put 3 here, 3 minus 3 is 0. 0 times anything equals 0. So I can't be 3 and I can't be -4. And on this one here, x cannot equal to 0, because if x is 0, then 0 times anything is still 0. And then x cannot equal to -3. Okay? So we state the restrictions there. Simple as that. Let me clear that. So that is a rational expression. Let's fast forward a little bit. So I think he's going to go through them, but we can fast forward. We can see. All right. All right. Okay. There you go.
Before we move on to simplifying rational expressions, I want to point out a couple rules and maybe a couple key mistakes people usually make to try and avoid those right from the beginning. So when simplifying rational expressions, people tend to want to cancel out x's and numbers whenever they can, which is good as long as you are canceling out only when fractions are being multiplied. So in this example, we have x over x times x plus 1 over x. So we have on the top multiplying. We can.
Yeah, so in this case, the only thing you can cancel out is the x's, right? So that's pretty straightforward. I can only cancel out this x and this x, right? Because this x is multiplying everything in this bracket. I can't cancel out anything that's inside this bracket here. I can only cancel out what's outside the bracket that matches what's in the bottom. Okay, over here I can cancel out this x, and I can cancel out this x, right? And possibly I can reduce we got 6/4. What's the greatest multiple that can go into 6 and 4 is 2. So I can probably cancel out, I can turn this 6 into 3 because I'm going to divide the top and bottom by 2. Okay. So that's what you're looking at there. Okay. Does it talk about it? He's going to do the same thing I did. So basically your answer is going to be x plus 1 if you do that. And then the answer is going to be, I believe he's still writing it like that. Okay.
Here is an example of what you are not allowed to do. So if you're looking at this page, make sure you listen carefully and read carefully.
Yeah, so you can't do this, right? Just don't even try. You cannot, like, this is like a binomial up top. I can't just take out this x and divide it by this x on the bottom, right? These two are together. The only way I can cancel anything on the bottom if I have a bracket around here, like you saw in the previous example, and there's an x outside. Right now, you can't cancel nothing here. Nothing, and same thing with here. Nothing can be canceled. Okay, just remember that. Let's fast forward a little bit. Same thing in the bottom, can't cancel nothing, can't cancel it. You can't cancel out that 2 either. Don't think you can touch that 2. Okay, so now we have a rational expression and we want to simplify it. Okay, so how do we simplify this rational expression? And I'm gonna let him play for a little bit, then I'll talk.
Simplification here by canceling out one factor of x in the top and the bottom. So I have an x times an x in the numerator, that's what x squared means, and an x in the bottom. X to the 2 divided by x to the 1. When dividing powers at the same base, you subtract the exponents, it gives me x to the 1. So basically, one of those x's is gone. I'm left with an extra 1 on the top, and this x is gone. So what I'm left with is a 3x in the numerator and just a y in the denominator.
Hopefully you got that right. So with this case here, there was x squared on the top, and the bottom was just an x, right? Even though it's an x, you have an imaginary 1. X to the power of 1 is just x. We never put anything to the power of 1 because it's just a waste of energy. X to the power of 1 is just x. So, but it is to the power of 1. Now what happens is if you use your exponent rules, right? Again, let me make sure you guys can understand that part. The exponent rules, right? So using the exponent rules for here, right, with my x's, I'm going to have x to the power of 2 minus, or sorry, it's divided by x to the 1. It's the same thing as me saying x to the power of 2, sorry about my pen, divided by, my pen is acting up. Okay, it all means the same thing, right? I subtract the exponents. So in the end, I'm just going to have x to the power of 1, right? Because it's going to be x to the power of 2 minus 1. And in the end, I'm just showing you, you guys probably know this. Hopefully you do from like grade 9, the exponent rule, right? And that's just basically x. So my answer here, that's why I got x here, okay? So that's my answer, okay? Hopefully you guys got that. Let's fast forward a little bit. Okay, so now once you simplify, you got to state the restriction. Y cannot equal to 0. Why cannot? Why or because? If it is equal to 0, you're gonna have an error in the bottom. So y cannot equal to 0. Your restriction is y cannot equal to 0. And I believe we're done with that. Oh yeah, and also x cannot equal to 0. And why we say x, even though the final answer is no x at the bottom, we go back to the original question. Over here, you have y and x. Both y and x cannot equal to 0. Okay, even though your final answer just shows just y at the bottom, but x was there at the beginning. Okay.
0 as well. Here's our simplified expression. Here's our restrictions on the denominator. Next example. In this case,
so we got to simplify, right? So if we got to simplify, we got to look at the bottom. There's really nothing you can do with the top. X minus 3 looks like that's as low as it can be. But the bottom, x squared plus 3x minus 18, can be simplified. Right? Because I can turn that into factored form. So factored form means I'll have two brackets here. Right? And looking at this, I can use product and sum, right? So when I say product and sum, I'm going to have here two numbers, right? Let me not do that like that. Oops. Two numbers that multiply together that give you minus 18. And then two numbers, when you add them together, gives you 3. Anyone help me? What are the two numbers? Say something in the chat. Remember, the chat records your participation too. Anybody? Oh, okay. Michelle, minus 3 and 6. If I plug in minus 3 and 6 in there, use a different color. Minus 3 and 6 gives you 18. Minus 3. Okay. And 6 add them together gives you 6. Okay, so therefore, x is minus 3, or x minus 3, and then x plus 6. Okay, so now when I look at it, I can cancel my x minus 3s, and therefore I'm just going to be left with x, come on, minus 3. My bad, that's wrong. There's nothing up top. It's already canceled x. So I'm just going to left with 1 over x, x plus 6. Okay. Sorry for this issues I'm having with my pen. So if I go back and do the restrictions, maybe I'll change the pen size. This is starting to get annoying. Give me a second, guys. Okay. Okay, let me try that again. So restrictions are x cannot equal to 3 and cannot equal to -6. Okay, I had to go back to the original, not just here. If I just look at here, I'm just gonna have x plus 3 and I can say, oh, and it can't equal to -6, but no, I had to go back to the original up here where x cannot equal to 3 or -6, okay? So let us fast forward that. Hopefully you guys can see that and then we'll kind of see the answer. I'll step it through. There you go. These factors that out. There you go. There you go. That's the factored form. You can see you cross it out. There you go. Okay, so that's what we just did.
second factor. There's our simplified expression.
Okay, so the next example. Next example, sort of the same thing. Two numbers that add up, and we can do this one. And let's see, we're just doing this one together. I'll use a different color this time. So we're saying two numbers that add up together to give you 10, and two numbers when you multiply together gives you 21. What are those numbers? Anyone? Oh, people are just jumping into the chat now. That's good. Let's see here. Move that out of the way. What are you guys saying? Yep, 3 and 7. Okay, so that's right. 7, 3, 7, 3. Okay, so my numerator is going to be x plus 7 bracket x plus 3 divided by x plus 3. Well, you know what? I can cancel out my x plus 3's, and then I'm left with x plus 7 over 1, because that's gone, but it's actually just equal to x plus 7. Now I have to state my restrictions, and when I state my restrictions, I have to go back to the beginning. X cannot equal to, well, at the very beginning, I had my denominator was x plus 3. Right now, my denominator is gone. So the restriction is, if you draw this, it would be a straight line, but I'll have a circle at -3, because x cannot equal to -3. Otherwise, my denominator is going to be 0. Okay. Simple. Okay, let's fast forward through that. And that's what he's going to do. So you can see. Okay. So I'm going to kind of skip through this because I know we're going to run out of time. But basically, we're doing more examples of this, right? It's the same sort of thing, right? Same sort of thing. More examples of that. Here's another one. It's basically you have the numerator and the denominator. In order for you to simplify, you would have to simplify, but then you'd also have to know how to factor, right? Turn things into factor form. This one is difference of squares, right? So you're gonna have x minus 3 bracket and then a bracket x plus 3, right? For that one, and the denominator, basically the two numbers that add up to 7, then they multiply, give you 12. That would be like what, 4 and 3, something like that, right? So you'd have 4 and 3. There you go, and then you do the same thing, right? So we don't need to keep doing it. And then your restriction would be, with this case here, your restriction would be -3 and then -4. You can't just say -4 because that's what you have at the bottom. You can't just say that. You got to say what's the original up there. Okay. So there you go, -3 and -4. Okay. So it's more of the same. I'm not going to go through this. I'm going to fast forward this and go on to the next video because it's more of the same. Okay, guys. So let's go on to the next thing while we still have some time. We got to look at multiplying expressions. We still got 3 more videos to go to, so I'm gonna have to kind of skim through some of these, and you guys may have to look at it your own, but hopefully you guys know where to find it. So this one here is multiplying expressions.
A continuation of the lesson on 2.1/2.2 simplifying rational expressions. In this part of the lesson, I'm just going to do a few quick examples of how to multiply rational expressions. These are the steps we're going to follow. So first of all, you're going to look at the numerators and denominators of both the irrational expressions, see if there's anything you can factor. And then once it's been factored, see if there's any factors that you can cancel out. Then what you'll do after you've simplified, and keep in mind when canceling common factors, when multiplying rational expressions, you are allowed to cross cancel. But this is
okay. Let's get into an example. That's one we're going to understand. Here, there you go. You got two rational expressions, right? Two fraction expressions here, and they're multiplying each other. That dot means they're multiplying. So The best thing to do is seeing if you can, within the rational expression, can you simplify it and then can you cancel? So you're gonna look at the first term or the first rational expression, which is this one over here. And let's see here, right? So I can factor out the 4 here. And so I have here x plus 6. At the bottom, I can factor out the x. So I'm just gonna have here x bracket x plus 8. Okay. Then on the other side is really nothing I can do in the top there. The bottom is really nothing I can do there. Okay. Oops.
When you get your next big idea, say sparkly ketchup.
Okay.
But if
Sorry about that.
I get x plus 6.
Yeah.
Now this is where the cross.
So back to this one here. I can't do nothing about the 12x squared, but I can do something about the 3, right? 3 or the bottom 3x plus 18. 3 can go into both the 18 and 3. So I can factor out the 3 and I'm just left with x plus 6. So now when I look at this, because I'm multiplying, I'm allowed to cross multiply or cross cancel. So I can cancel this one and I can cancel this one because they're basically, one's the numerator, one's denominator, I can cancel it out, right? I can, with this one, here I have an x and I have an x squared. Well, remember, it's like saying you can subtract the exponents, right? Just like the exponent rule. So I can turn this first of all, this x is gone, but then I'm left with just a 1 here because I subtract the exponents. Remember, x is like saying x to the power of 1, but you never say to the power of 1, we just say x. But if it's x to the power of 1, and then I have here x to the power of 2, I can subtract the x, I can subtract the 2 minus 1, okay? And then my question is gonna be more simplified. So let's continue. Okay, so he's doing some canceling, right? Oh, I missed that. You can divide 3 into 12. So 3 goes into 12 and it's going to be 4. So I missed that one. Okay. And now I'm just going to have 4 times 4 and then 4x. So let's go to the bottom. Right, this is what's left over after simplifying. So 4 times 4x gives you 16x divided by x plus 18. Or plus 8. Now, my answer is done, but I got to state my restrictions, right? And my restrictions are going to be based off over here, my original expression, right? So x cannot equal to 0. That's 1. If x is 0, that means everything is 0. X cannot equal to -8. And then x cannot equal to -6. So that's my final answer with the restrictions. Can equal to 0 at -8, -6, and 0, like I said. Okay.
Next one. So second of 3 examples. Once again, we're going to start by factoring what we can. In our first fraction here, we can factor the numerator by common factoring an a and be left with a plus 2. And remember, whenever you're...
Okay, again, you do the same thing, do the find common factor, see what you can separate, okay? And basically, once you do that, then you start canceling, you can cross cancel. I'm gonna fast forward this one because this one is not that hard. Okay, I'm just gonna go through it. Right, so now I have 20a squared. So this is what I have. So if I'm gonna state restrictions, I can start stating restrictions from here. A cannot equal to 0. A cannot equal to -2. Okay, right from here. Cannot equal to 0 on both sides, on both these things you're going to multiply, and then it cannot equal to -2. Now let's see what I can, cancel, right? A times A is squared. That means I can cancel out the a squareds. So I'm just going to left it with a up top. Okay. The other thing I can cancel is a plus 2. I can cancel that. Let me use my, I can cancel that, and I can cancel that, because that's going to be multiply a times a squared, so that's canceled. And I can cancel a plus 2. And I can also say, well, 5 goes into 20, so I can cancel out the 5, and this 20 turns into 4. Okay. And I believe my answer is just going to be 4a over 3. I believe that's the answer. Maybe I'm wrong. I just kind of went quickly with that. Let's see. Let's fast forward a little bit. Let me clear my answer. So 4a over 3 is my answer. Another commercial.
Blinds to Go shop at home service. We bring the showroom to you. Blinds to Go. We make it easy.
1 times 4a is 4a, and the denominator 3 times 1 is 3. Now you don't see any.
Okay, so there you go. So that's basically what we did, and then the restrictions, it's just gonna be from the beginning. Cannot equal to 0, cannot equal to -2. Let's go back. There you go, 0, -2. Okay.
The restrictions stated. And we'll do one more example where we have a quadratic that we're going to have to factor.
Okay, so the only difference with this one, you have to factor this one out. 2 numbers that add up to 4 and 2 numbers that multiply give you 3. Well, I think it's going to be 3 times 1. 3 times 1 gives you 3. 3 plus 1 gives you 4. So I'm going to make this into factored form, and then I can see what I can like cancel. So that's in factored form, a little faster there. Okay, so I can cancel out. I can cancel out the x plus 1, and I can cancel out this x because I have x up there. So I'm left with going to be 3 over 2 and 2 times x plus 1. That's what I should have. Let's see here. Yeah. Okay. There you go. That's all is left. And my restrictions are going to be x cannot equal to 0, cannot equal to -3, and cannot equal to -1. Okay, so fast forward a little bit, it's going to be just 3 over 2, and those are restrictions. There you go. Okay, so I think you get the idea with this one. I'm just going to change this one and go to the next video, which is dividing. Dividing is similar to multiplying. It's like multiplying fractions, right? Or dividing fractions. You multiply the reciprocal.
Okay, here's the last part of the 2.1/2.2 lesson on simplifying rational expressions. I'm going to do a few examples on dividing rational expressions. So in the previous lessons, I taught you how to simplify and state restrictions. Then I did a couple multiplying rational expressions examples, and lastly, we're going to do a few dividing rational expressions examples.
Okay, so with this one here, it's similar to, it's just like, dividing fractions. You multiply the reciprocal, right? The reciprocal would means now it would be 12b squared over 15a squared. Okay, so let's look at that. There you go, it flipped. Now from here, then you just multiply and do the things you did from multiplying, right? Right, so here I have 4a and I have a squared. I can put them together. Well, actually, you know what? We can do things quicker. I can cancel out this a and this a. And I'm just left with just a squared. And I can, well, one of the things you can do is 10 times 120. Let me write this out. I'll go this way. It's going to be 120. right? Over, and now 4 times 15 is what, 60? And okay, that's the coefficients, but then I have b and or b squared and b squared, so that's going to be b to the power 4, right? And at the bottom, I still have my a squared. Okay. Can I go any further? Well, I think 60 can go into 120, 2, and it'll be 2b to the power 4 over a squared. Okay, let's see if I'm right. I think I'm right. Right, there you go. Another commercial.
Listen, there's a good chance somebody's trying to hack your website right now. You gotta make sure.
Times. Now what we're going to do is look for more canceling that we can do. I can cross cancel these 5s, because keep in mind that 5 is being multiplied by the b squared, so I can cancel that. And this 5 is being multiplied by the a squared, so I can cancel that. You can only cancel things that are being multiplied by everything else in the numerator and the denominator. Now I can multiply it out to 4 over 1 times a squared, which is just a squared. Nothing else I can.
Okay, you see we got the same answer. Now we have to state the restrictions. The restrictions, if you go back to the beginning, is basically a cannot equal to 0 and b cannot equal to 0. Even though our final answer is no b in the denominator, there was b at the beginning. So you got to make sure you say b cannot equal to 0 as well. Okay, so let's see here what he says. The restrictions. Okay, let me just clear out my mess so we can see it properly. Right, a cannot equal 0 and b cannot equal 0. There you go. And we have another example. With this example, what do? You multiply the reciprocal. So the first thing you do, even though this is divide, multiply the reciprocal. So you're going to flip it. Right, so it's going to be 20a squared as the numerator divided by 5a squared plus 10a. Okay, now you can see if you can factor things. Remember this one here, you can't really do too much because it's all together here, but you can factor that out separately. So let's go step by step here. Could I do that? No, I can't. So what are you doing here though, is put this in factored form. Factor out the a for here, and you're gonna have a plus 2. And even here, you can probably factor out the 5a. And if you do that, you're gonna have here a plus 2. So you have the 3 over there, and you have 20 up there, and you have, like I said, 5a comes out, and you're gonna have a plus 2. So now I can cross out the a plus 2s, and I can also cross out the a up over here, because I'm gonna have here a squared minus a, divided by a. I'm just gonna have a to the power of 1, which just means a. Okay. So I'm just left with over here 1 divided by 3, because everything got canceled out. And on this side, it's going to be 4a. That's it. So times 4a. Right? And therefore, it's going to be 4a over 3. So then the restrictions are a cannot equal to 0. And yeah, that's it. A cannot equal, a cannot equal to 0. And then a cannot equal to -2, because you have this one over here.
All right, and we'll do one more example where.
Okay, so this one here is sort of a long example. Okay, what's happening here is, again, you multiply the reciprocal. This says divide, that means you're gonna have x squared minus 9x plus 20 up top, divided by 4x in the bottom, okay? But then after you do that, then you wanna change everything to factored form, right? So this one's gonna have to be in factored form, and this one's gonna have to be in factored form. So let's just continue. Okay, now let's put things in factored form. X squared minus 3x minus 10. What two numbers add up to minus 3 and multiply to minus 10? What are the two numbers? Someone help me out. I need your participation. Okay, minus 5 and 2. Michelle again. Okay. So that means you're gonna have bracket here, x minus 5, and then bracket x plus 2. And up here, two numbers that multiply, they give you 20, and then two numbers, when you add them together, gives you -9. Who's gonna give me that answer? There you go, a few people, right? So let us write it down. That's what this is. And then over here, it's gonna be x minus 5 and then x minus 4. Okay, guys. Sorry for that pause. I was just thinking. There you go. And now we're left with, so the x minus 5s cancel. We can see they're canceling out. And what else cancels out? My x's cancel out over here because I have an x up top and I have an x in the bottom. So this x squared in the bottom turns into 1 and I have an x up there, right? So that x is gone. And then this 4 here, I have a 4 here and I have a 2 up there. They can basically cancel each out. I can have,
Numerator, I have x minus.
I have 2 that can go into there, cancel it out. That's just going to be a 1, and then over here 4 and 2 into 4 is just 2. Okay, so that's what's going to be left. When I multiply the top, it's going to be x minus 4 times x minus 4, and the bottom is going to be 2x times x plus 2. Okay, now can I simplify more? Not really. Now I can state my restrictions. So going back to the original, x cannot equal to -5. Sorry, x cannot equal to 5, and x cannot equal to -2, and x cannot equal to 0. Okay. Okay, so I'm fast forwarding. Looks like this is it. All that. There you go. -2, 0, 4, and 5. Okay. So we're done with this one. That's dividing. Now we're gonna go into that was dividing rationals. Now we're gonna go into adding and subtracting. Adding and subtracting is a little bit harder. It's just like adding and subtracting fractions. You guys never liked that in grade 9, right? Where you had to add fractions or subtract fractions, because you know what you would have to do? We'd have to find the common denominator in order to add or subtract. Same thing in rational expressions. You have to find the common denominator. Otherwise, you cannot add rational expressions or subtract them.
Okay, so here's a continuation of section 2.2 for the functions 11 course. I've already taught you how to multiply and divide rational expressions, so what I'm going to do now is teach you how to add and subtract rational expressions. So just to help a reminder before we actually get started working with rational expressions here, that when adding fractions, like let's say we had 1/3 plus 1/4, you need a common denominator. And to get a common denominator, a useful tip that will always get you a common denominator. Now, it might not always be the lowest common denominator, but it will get you a common denominator, is to just multiply the denominators together, and that'll tell you what we want our common denominator to be. So for example, 3 times 4 is 12, so a common denominator between 3 and 4 would be 12. So we can make this fraction have a denominator of 12 by multiplying the top and bottom by 4. We can make this fraction have a denominator of 12 by multiplying top and bottom by 3. And then we would have 4 over 12.
Okay, commercial.
This is Dave, head of marketing at a ketchup company about to use Grammarly to handle a tight deadline. 2 weeks? Not ideal. Good thing Grammarly's tone suggestions can help move things forward, because conveying confidence can make the impossible feel possible. Now, you just have to tell your team.
2 weeks?
You got this, Dave. The right positive tone can quickly motivate them, because there's work to do and a new product to launch. Now look at y'all, looking good.
Okay.
Plus 3 over 12, which gives us, of course, 7 over 12. And remember, when adding, you add the numerators, keep the denominator the same. But we need to get a common denominator, and a tip to help you get a common denominator is just multiply the denominators together, and that'll tell you what we want our common denominator to be. And don't forget, whatever you do to the bottom of a fraction, you also have to do to the top.
Okay, so we know this stuff, right? We should know that. Now let's get into some rational expressions, right? You can see these ones are not common denominators, right? This is x minus 3, this is x plus 2. What do you have to do? You have to get them common. So the common denominator would be a denominator that has x minus 3 times x plus 2. That'll be common denominator. And as a result, you have to figure out what do I have to multiply this term in order to get the bottom x minus 3 times x plus 2. That means I'm going to multiply x plus 2 top and bottom. Let's just look at that. Common denominator, okay? My common denominator is going to be x minus 3 x plus 2. So I'm going to have to multiply top and bottom of this fraction by x plus 2. And on this one here, I'm going to have to multiply top and bottom by x minus 3. Okay. There you go. So now I'm going to have one common denominator, right, which is x minus 3. Okay. Sorry, x plus 2 and x minus 3. So this is going to be, and then I have to add this one over here. So now watch. Now, common denominator, so one denominator, but now these two I'm going to have to add. So the only way for me to combine the top is I have to turn this into standard form. I have to use my FOIL method. Okay, so that means I have to turn this to standard form. That means FOIL method. If you remember FOIL method, right? Let's just FOIL method this out together, right? So we're saying I have to multiply this times that first, outer, inner, last. First, outer, inner, last. So my next line is going to be one denominator, which is going to be just x plus 2 bracket x minus 3. Just one denominator, right? But the top, when I multiply this out, I'm going to have here what, x squared, and I guess those two numbers there, that isn't minus 3. I can't see there, but I guess my last is going to be a plus. Is that a plus? Oh, that's a minus in there. Oh, that's plus 5. My bad. I can't see that properly. My bad. So I'm going to have here, that's plus 5. I'm going to have here plus 7x, and then plus 10. And then over here, when I'm done with this stuff here, I'm going to have here x. So it's plus x squared. And then I'm going to have here negative 7, negative 3x, I'm going to have negative 10x. And then I'm going to have negative 21 times negative 3, sorry, times negative 3 times 7 is going to be plus 21. Okay, what happens is I combine like terms now, right? That's what's gonna happen. So I get all this combined like terms. And then I'm gonna have an expression on the numerator. I don't have much space. So I'm gonna have to like clear this a little bit and then let him play it out and let him show his answer. But that's what's gonna happen. So you can see the numerator is being built up here. Now here's one denominator, okay? Now he's gonna do the FOIL method, which I just showed you. Okay, there you go, x squared plus 7x plus 10, that's what I did before. And there you go, and all over one denominator. Okay, now combine like terms, so I have x squared and x squared becomes 2x squared. I have 7x and minus 10x is gonna be minus 3x. And I got 10 plus 21 is gonna be 31. There you go, all divided by x plus 2 bracket x minus 3. Okay, another commercial.
Okay.
Okay, so then now can we, so now you're looking at this, and that's a matter of can we factor this out? Okay, turn this, the numerator, see it's a lot of steps with this one. Now you gotta turn this one back into factored form because that's the only way you can like cancel things. When it's in brackets, you can cancel. When if it's not in brackets, you can't cancel. So now two numbers that equal to the multiply together give you 62, and then when you add them together, give you -3. What could those two numbers be? Two numbers that add together to give you -3. When you multiply them together, you get 62. Let's see. Oops, I think I went too far. I'll play it from here.
So we haven't canceled anything out. So my restrictions are x just can't.
Yeah, so basically I couldn't get this into factored form, so we're stuck there. So that's fine, you can't do that. But you still gotta state the restrictions. The restrictions you can see here are -2 and 3, but you have to go back to the original. And I think the original is, I think that's it. It's still gonna be -2 and 3.
Be -2 and 3.
Okay. So now you can go to the next one. I'm about over with my time, so I'm just gonna fast forward and do one more example. But this is what basically you're doing. Now the other one was a multiply, was adding rational expression. This is now subtracting rational expression. So it's like basically subtracting fractions. Okay, same sort of thing. You have to get the common denominator. So one of the ways when you have it like this, you have to turn it into factored form. That means factored form is you want them in brackets. So it makes it easier, right? Otherwise, this is just going to be a calamity. If you can't get common denominator with this. It's just, so you have to get it in factored form. It makes it easier. Okay, so we're going to go through in factored form. So starting with this one here, two numbers that add up to 2, then two numbers that multiply give you -48. I think that would be 8 and -6, I believe, for that one. And then this one here, two numbers that multiply to give you 30 and or -30, and two numbers that when you add them together gives you -1. So I think that would be -6 and 5. -6 and 5 gives you -1. -6 times 5 gives you -30. So I think we have them all. So let me fast forward. There you go. For this one, it was 8 and -6. And this one was, yeah, -6 and 5. Okay, so now you need to have common denominator. That means you're gonna multiply this whole thing here by this denominator, and then multiply this whole thing here by this denominator. Or you can look at, if I look at both these denominators, what would make them the same? Well, what would make them the same would be if I multiply this top and bottom by x plus 5 over here. And if I multiply top and bottom, x plus 8 over here. Let's just fast forward that because he's going to show that. A common denominator. Okay. There's your common denominator, all those three factors. There's your common denominator. So here I can multiply x plus 5. And over here, I'm going to multiply x plus 8. Okay. So that's my common denominator. So now I'm going to multiply these things out. I'm going to multiply these things out, and I'm going to have to get them. So to multiply these things, x minus 9 times x plus 8. That's using the FOIL method. Okay, so let's just continue. Next line, there you go. Just going to write it out like that. So there you go, x minus 9 times x plus 8 for that. X plus 5 times x plus 9. Now you do the FOIL method. Okay. And after the FOIL method, you combine and get like terms. First of all, right now you can look at what are the restrictions for x. X cannot equal to -8 because I have a 0, cannot equal to 6, and cannot equal to -5. Right away, I know my restrictions. Now it's a matter of giving me the top in FOIL using the FOIL method, and then getting out the adding up the common denominator. So let's go. There you go. So you see there was a minus here. I have to keep that minus there. If I don't, I'm going to mess everything up. So I still have this whole thing in brackets because this minus applies to this whole thing here. So I have to keep it there, and I have a bracket. Then I do the FOIL method. So x squared, right? And then I'm going to have here minus x or minus 9 times 8, -72. And then I have 1x or just x. -x, okay? So combine like terms, that means if I do that, these x's would cancel because this minus will turn everything in here the opposite sign, okay? Let's see if he does that. There you go, everything inside here becomes opposite sign. This becomes -x squared. This becomes, that was a -x, now it's a plus x. This was a -72, now it's a plus 72. All divided by x plus 8 times x minus 9 times x plus 5 is my denominator. Another commercial. Let's fast forward through that.
I like terms. X squared minus.
Okay, and then we get to the final answer because we're going to combine like terms for the numerator, and that's what we get. And our restrictions are what we see there. Okay, this concludes the video, the Zoom session. Okay, here are questions you guys can work on to practice for each one. Multiplying, simplifying, then multiplying and dividing expressions, and this one is adding, my bad, this one here is adding and subtracting rational expressions, okay? And you have a quiz that is due today, okay? Okay, so I will stop the recording at this moment in time. I'll stop sharing and I'll stop recording, and our session